Taking a look at number 68 here, I'm going to try to take this longer sentence and rewrite it into a short sentence and then solve it from there. There are different ways that I could even structure the sentence, so I'll try to give you a little bit of example of that variety. And I'm going to zoom in some so you won't see all the directions here, but they're going to want us to round if necessary. Okay, that's a helpful piece of information. Let's zoom in a little and go ahead and get started. Alright, so we've got 500 people, 20, say the favorite color is black, so what percent of the people? So it's saying what percent of 500 is 20. Okay, so it's what percent of percent of 500 is 20. Alright, this could also be worded a different way. You could say, well, it's not going to matter how I'll say 20 is what percent of 500. Both these sentences are asking the same question. And another aside is you could just realize that this is 20 of 500. So if I just wrote, let's kind of move over here, still want to be on the page. I could just say 20 of 500 is what percent? Alright, they're trying to, this could actually just reduce, if this is over 100, that will tell me the percent, right? So just notice this denominator is kind of convenient to work with. I could divide by 5 and divide by 5. I'm actually even going to get away with ignoring all of the work I've sort of given myself, because this will just reduce to a denominator of 100. So if I divide 20 by 5, I get 4. If I divide 500 by 5, I get 100. 4 over 100 is the same thing as 4%. Alright, so I can just write 4%. It won't usually be this straightforward. Okay, sorry I went off the page a little there for a moment. But let's just say that this didn't occur to you, or you didn't have such a convenient denominator. And actually, as I said, I didn't even really deal with what I had set up. If I go through all the mathematics here, I'll still come to the answer of 4%. But this was just a convenient case where simply reducing this got it over 100. So the answer is 4%. I'll take the longer road perhaps in a minute. Okay, but if we had gone with our direct translation, from here you can go to an equation. Remember, for what percent, I kind of fudge it a little bit and I just put an X there, but in the end I'm going to have to come back and change this answer to a percentage. Of 500 means times 500 is 20. Alright, so here you would, to get X by itself, you would divide each side by 500. Notice what we ended up doing here. Okay, and then if you translated this one, you would have 20 equals is what percent of 500. And again, here you would divide each side by 500 to get X by itself. Okay, maybe I'll just finish out this one since this is where I seem to have more room. I guess I can zoom out one so this all fits. There we go. Okay, so you want X by itself. So divide by 500. Divide by 500. Goes into itself one time. You have x equals this is where I'm going to end up, but you might see me getting there in a rather unusual way, just because it's unusual that the denominator would clean up so nicely. So if I take the long road and just say, okay, 20 divided by 500, here is, where am I going to do this? I'll zoom out one more. That'll give me plenty of room. Alrighty. So if we have 20 divided by 500, notice it doesn't fit. Put your decimal here, tell the world, load up on zeros. 500 into 200, that's 0. 500 into 2,000, it goes 4 times. And that gives us 2,000. So there's nothing left over. So I got x equals 0.04. And remember early on with this sentence I said, well, for what percent I'm representing it with an x. But just that x by itself does not represent a percent. So at the end I have to change this to a percent. So if I have 0.04 or 400ths, and I want to write this, I want to put in a percent sign. If I'm going to put in a percent sign, I have to move the decimal 2 places towards it and put in the percent sign. So okay, if you want a 0 here, you can put it in 4.0% or just 4%. Okay, and that's what we ended up with. I know this was a much shorter road, but you can't really depend on them to give you a denominator that's going to work so nicely. What if they said in a recent survey of 471 people? See, you wouldn't be able to get that to 100 very nice and neat. All right, so there's a couple examples how you might have approached number 68. And I guess I should also finish this up showing what would happen if I had used the proportion that I set up. So let's take a look at that. 20 is on top, of 500, of on the bottom, percentage x over 100. When you use a proportion to set it up, x over 100, that takes care of the what percent. Okay, because this sign stands for basically over 100. So all I do is solve this proportion and the decimal has already been moved. Okay, so if I didn't know about my little trick here, let's just cover that up. There we go. And I would say, well, I want to get x by itself, and right now it's being divided by 100. So let's multiply each side by 100. I know that 100's rather small, but those go away. You get x equals 100 over 500. Get rid of all those zeros. So 100 divided by 100 is 1. 500 divided by 100 is 5. So you just have 20 over 5. 20 divided by 5 is 4. And remember I said this already took care of the percentage, the decimal moving around. That's already taken care of. All you have to do is remember to put in the percent sign. Okay? So that's a lot of different ways you could have tackled 68. Number 70, let's zoom in some and take a look at that one. Okay, can I handle one more? Yeah, it works fine. Okay, enrollment decreased by 15% by the enrollment of 1,200. Again, I'm going to try to write a short sentence that's restating this longer two-sentence approach. Now, let's see here. You need to read it and reread it a little bit. Decrease in enrollment. So how much did it go down? So it's really saying 15% of 1,200 is what number? All right, they say find the decrease in enrollment. They're not asking for okay, over last year. So this year they're not saying how many students are enrolled this year. They're saying by what measure did it go down. Okay? So this direct translation will work very nicely here. 15%. It's actually easier to do this as a fraction, but I know most people would rather see a decimal, so I just changed 15% to a decimal. When you get rid of the percent sign, the decimal goes away 2 spaces. Oh, I forgot my word of in here. You notice that? Maybe I'll make that green so it doesn't look like part of everything else. 15% of 1,200 is what number? So that means times 1,200 equals x. So you simply multiply these two. It is more work than a fraction. That's unfortunate. I'm going to do my calculation. I could do the multiplication, but it's more work than using fractions. So off to the side here, I'm just going to write 15% as 15 over 100 times 1,200. 15 times 12. Well, I guess it didn't save me a ton of work. Alright, let's skip that, even though it's still easier. I'll stick with my longer road here. So we'll do that calculation over here. And we're multiplying. 10, that's 5, 6. And then you have to put in a 0 here before you even start. And now 1 times 0 times 0, 2 and the 1. And what do we have? 2 decimal places. So that's 180. All right. So there's 180 fewer students. If they said what is the current year's enrollment, then you would have to subtract 180 from 1,200 after you got this answer. And just notice here, if I had multiplied 12 times 15, I just would have gotten 180. All right. But I decided, since that wasn't completely simple, it wasn't automatic in my head, I just went with the longer road and kept up with my decimal. All right, so that takes care of 70.